My name is David Godow. I'm going to talk about how to make CSS functional. That's right, it's a pun. It's pretty cool. I think it's that time in the afternoon when we need to start off with some corny, mandatory audience participation. So please raise your hand if you enjoy CSS and you're doing web dev projects. Okay, 1, 2, okay, less than 10%. What about if you hate CSS? It's the worst part of the process for you. Yeah, okay, about 50%. Turns out a lot of the world agrees with you. CSS, I realized when I was thinking about this, is basically the DMV of web development. You can't do without it. You have to confront it at least a couple times in your lifetime or in your career, but you hate to do it. And so you try to avoid it as much as possible, at least if you're like me. In fact, CSS is so widely hated that it's actually kind of boring to talk about how much you hate CSS. You've probably seen this whole line of products. CSS sucks, CSS kind of sucks. You've certainly seen this before. And when I was doing research for this presentation, I actually came across so much of this that I realized that it's gone too far. So people are actually talking about how it's no longer cool to bash CSS because people bash it so much. So I have to admit I'm in this camp. I'd like to say I'm doing this talk because I'm really excited about this awesome technology, but I actually really dislike CSS. I find it really difficult to get through. But functional CSS, which I'm going to talk about, has made it a lot easier for me to kind of get over that hump. So I want to kind of review a few of the common frustrations with CSS. Starting with the fact that it can be complex to reason about. That's really just a fancy way of saying that there's a lot of weird magical CSS hacks to do basic stuff. And there's not a lot of real kind of hard logic in the same way as you might see when you're doing any other sort of programming problem. What I featured here in the bottom left is one formula for vertically centering a div. I don't really understand why negative margins should be a thing or what top 50% means, but just kind of a common example of why CSS can be difficult to wrap your head around. Another issue, especially in big projects, is extreme specificity of classes, especially when you're using maybe a CSS framework or tool. You have a lot of classes because you're getting very specific when you're trying to style an element. That can be really difficult to maintain later on in the project when you might have several elements that are styled this way. Someone else who looks at the project may not know exactly what the class refers to. It's just really difficult to kind of reason about the architecture of your CSS beyond just kind of getting things done in it. Finally, mutability and side effects. In some ways, this isn't a problem because it's kind of built into what CSS is. Cascading style sheets means that you have a lot of what are essentially side effects, the cascade, influencing how one CSS selector might actually appear on a screen. So you might have something here, like you're trying to center something horizontally, but it doesn't work because of some other part of the cascade that has essentially outmoded this. That's why you have Chrome Dev Tools to kind of help you reason through what your CSS actually means, but it shouldn't have to be that way. So obviously, there are a lot of tools, some of which we know pretty well, to help you use CSS. Preprocessors, I'm just going to lightly touch on, super useful, but not necessarily to make CSS easier to use on a structural level, but just help you do cool things like media queries, although variables, of course, are very useful. There are also a lot of existing design paradigms that I looked at, like object-oriented CSS or SMACs as well. BEM is a relatively recent one that are meant to help you provide more of a framework for understanding CSS, like you might any other programming language, or like I should say like a programming language. But I found them to be pretty complex and almost as difficult to understand and reason through as CSS itself. I want to give just one example just to kind of give you guys an idea of what, for example, object-oriented CSS is like. I'd encourage you to go look at it as well as SMACs if you have the time. But I want to give you an idea of why I felt there needs to be another solution to make CSS really easier. So yes, first of all, I know this is a lot of text. That's by design. It'll become clear in a second. But I've actually included some of the documentation for object-oriented CSS, specifically its container model. So it has 3 different containers. One is mod. It's pretty simple, right? Mod is the base container. All other containers inherit from this one. Then you have complex. which is complex should be used in cases where you require images for borders because borders or drop shadows are too complex to be simulated via borders on mod. So basically you're getting the idea here, right? Pop, this text is even smaller, right? This is really hard to read. Used for pop-ups and other containers that need outside transparency, compatible with any container but not any content. I don't know what that means. Choose when you require outside transparency which cannot be simulated. Do I need to make this work with clip rather than background? See, this is really difficult to understand. And just trying to get up and running on object-oriented CSS takes a lot of cognitive effort. So when I was trying to think about how to make CSS even easier, I really just came back to this question. It's like, okay, if none of these frameworks are really what I'm looking for, how can we just write what I want to see on the screen? That's really simple, right? Like that's what everyone wants to do. Just write the thing that you want to see appear on the screen. That's sort of the basic question of how to, I think, create logical CSS. And so I tried to look for something that would let me do that. Say, I want a div. I want it to have a solid red border of this size. I want these rules to apply only to this element. And I think that's going to make it a lot easier to reason through what my CSS is doing. I also came across this quote, this really deep cone-like quote from Adam Morse, who's the creator of the CSS framework Tachyons, which said, "The overwhelming majority of CSS you would need for your site has already been written." Whoa. The real way, here's the cone-like part, the real way to scale CSS is to stop writing CSS. That's what led me to functional CSS, which is not necessarily a framework itself, but a paradigm for how you would organize and write your CSS, sort of similar to object-oriented CSS. So the way to think about it at the highest possible level is a library of style functions, the library meaning the things that have already been written, in Adam's quote, that are called from the HTML. So this is basically like a really fancy way of doing inline styling, but in like a cool 2017-like way. Basically what happens is you write CSS properties like background color, text align, all that kind of stuff, and you put them in classes. So you just have a class that's like background color red. And then those get applied in your HTML tags under the class property. So as you can see here, this is a really simple example, but you could have a div. Let's imagine we have classes for width of 100 pixels, height of 100 pixels, centered, and then you have more specific styling for each of the text elements you might have inside of that. And this means that every tag is styled individually, so you know exactly what is happening stylistically in each tag. I'll talk about this in a second in more detail, but one of the side effects is this completely does away with the cascade. So all of those rules are basically thrown out the window, and what you're just thinking about with each element you write is what do I want this specific thing to look like inside of the larger container it's in. So what does it actually mean for CSS to be functional? Obviously CSS isn't a Turing-complete programming language in the way we think about them, but there are a lot of similarity, or rather a lot of principles you can draw from functional programming that apply to CSS. First is the idea of one input, one output. Like I was just talking about in functional CSS, you have one style for one element. So each element is individually styled, although you might use the same package of styles in different elements. The biggest one is probably no side effects. Like I said, this completely does away with the cascade and deals, rather does away with a lot of the unpredictability that comes with the cascade and other common CSS paradigms. It's also, in some cases, reasonably composable. So composability means you can have one thing that does many things. You can kind of have a wrapper around something. This method in some ways seems like it might not be like that, might not be composable, because you have to write each thing you want to do individually. But actually, there's a way in React to apply it in a very composable way. So again, I just want to kind of dive under the hood a little bit here to talk about how you might implement this in your projects. Basically, you have these reference style sheets that are libraries of all of these CSS classes. So you might have 25 different ones for common background colors. And remember, each of those is an individual class. That's what you see in the middle of the slide here. Then those get put into your HTML tags themselves, and ideally you won't be writing any new CSS when you're doing your project at all. You'll just be pulling from these libraries, these reference style sheets, and mixing and matching them. There are a couple of different frameworks that can help you do this. There's Tachyons, which is more heavyweight, but also more modular. Its syntax, as you can see in the bottom left, is also a little bit more complex and difficult to understand. Base CSS, which is what I've used more of, is more similar to just kind of writing HTML. It's more reliant on the native styles you have in HTML tags themselves, and a little more lightweight. Oh, but you're interested in React applications. Turns out Functional CSS has you covered. I'm going to touch on this in a really high level. I don't want to get too deep into the weeds here, but you can basically use functional paradigms to allow you to style each of your components when you're rendering them, which I think is super cool. So you set this up in this kind of simple way. You're instantiating a component. Let's say you're creating a button component. There's some syntactic magic that I'm going to really hand wave around because I don't want to dive into that. But essentially what you're doing here is you're using as arguments the types of styles you want to define in that button. And then you're basically creating a template for that component here. You're returning it, and whatever styles you define in the button will show up there at the bottom. So the way this actually gets implemented is something like this, where you'll have button, you have color equals red, BG color. These are all classes in your React component, and you've programmed in sort of the back end of this all these different attributes they can have. So BG can be black, BG can be red, BG can be blue, and this makes it a really makes it really easy to style your components on the fly without having to rely on CSS. Here's another example of how you might use functional CSS in Tachyons in a component. I'm not going to dive into that. So there's some assembly required. You have to obviously get to know these frameworks. You can do some customization. Generally, they aren't so blown out that they have every possible sized font. If you really need that 23.5 point or pixel sized font, and you have to do a lot of typing because again, you're styling every individual tag here. But I really encourage you to do some more research and experiment with this. Visit all those blogs if you're not convinced by what I've said. And if you're interested in God mode React, implementing those functional React components, here's a blog post that'll help you do it. Thank you.